Hi. This lesson will cover on the type of reaction, which is exothermic and endothermic reaction, drawing and interpreting energy profile diagram, and discussion on rate of reaction based on collision theory. Exothermic reaction is a reaction which involves more heat loss compared to heat gain. As indicated by this energy profile diagram, there is more heat loss rather than heat gain in this reaction. So generally we could say that exothermic is a reaction which has more heat being released to the surrounding. The product enthalpy is lower than the reactant enthalpy, which could be shown from the graph. The energy of the product is much lower than the energy of the reactant. And the delta H is a negative value. Delta H is heat of reaction. Delta H is solved based on enthalpy of product minusing the enthalpy of reactant. And based on this calculation, the delta H of an exothermic reaction would be a negative value. The y-axis of an energy profile diagram will be labeled as energy or enthalpy, where the x-axis could be labeled as time or reaction, pathway, or reaction coordinate. Now, as for endothermic reaction, the heat loss will be lesser than the heat gained in a reaction. Thus, generally we could say that an endothermic reaction involves more heat absorption, or it's a reaction which involves heat being absorbed to break the bonds. The product enthalpy is higher than the reactant enthalpy as indicated in the energy profile diagram. The delta H is a positive value. Rate of reaction is defined as the change in the amount of reactants or products per unit time. And this amount is something which is measurable in lab. Example, concentration, volume, or mass. As you're aware of, reactants are generally being consumed in a reaction. Thus, the concentration of reactant would gradually decrease as the concentration of product would gradually increase. Since the concentration of reactant decreases, you will observe a negative rate. As the concentration of product that changes, you'll observe a positive rate. Collision theory. There are three main key points in collision theory. First, for a reaction to occur, the reactant particles must collide. They must collide with correct orientation, similar to lock and key model. And these reactant particles must have enough energy whereby the energy of the reactant must be equivalent or more than activation energy. Activation energy is the minimum amount of energy required by reactants to overcome in order to form product. Let's look at a microscopic view of an energy profile diagram. In a reaction, reactants generally gain certain amount of heat energy, and the kinetic energy of the reactant will increase over time. And at certain point, as indicated in the graph, the highest peak of this energy profile diagram is called as the transition state, whereby the reactants would have attained the minimum energy required in order to form the product, and this is called the activation energy. At transition state, the species would appear to be activated complex, and these species are said to be unstable and only exist temporarily, after which the activated complex species would lose its energy as indicated by the reaction pathway, and eventually it will form a stable product.